Welcome. Thanks for tuning in. I'm Alex Williams, founder and editor-in-chief of The New Stack. We're coming to you live from Chef Conf here in Chicago with another episode of The New Stack Makers, sponsored by Chef. Chef's comprehensive suite of automation products can manage it all: infrastructure, runtime environments, applications, and even the DevOps workflow itself. Today we're chatting with Nell Shamrell-Harrington, who's a senior software development engineer at Chef. So thanks for joining us.
Thank you so much for having
Appreciate
me.
it.
It's an honor.
Great. It's really nice to have you here. And I just wanted to start off by saying I really did enjoy the Food Fight podcast, and you're one of the hosts on the podcast, and it was fun.
I'm so glad we were able to pull that off and do the live recording here because, we've talked about Chef Conf in previous years on a podcast like a week or two later, and while that works, it doesn't have the energy of doing it right then when everything is really fresh.
And you could tell there were listeners there because they were really excited to be there, and they could see everyone in person, so that's
Absolutely,
fun.
Yep.
So our discussion really is about the application automation process that we're seeing with Habitat, that build, deploy, and management capability that Habitat brings. It seems to me that the concepts of almost control planes are starting to become more understandable for people.
It's true. I tell people, so 2 years ago, I would go to a conference and ask someone, have you heard of Habitat? And the answer would be no. What is it? Last year, it was, have you heard of Habitat? And the answer was yes. What is it? This year, I'm not getting the what is it question. So it seems like it's finally hitting the sweet spot, both in the market and the collective psyche of the technology industry, and saying, oh, this is important. We need this. And this solves a problem that we have.
How has it changed, and how do you describe it now? How do you describe Habitat to people right now?
Right. I describe it personally as two things. The first is a packaging system. And what you do is you create a plan file for your application. You write the application first, and then that plan file defines in Bash for Linux and PowerShell for Windows how exactly that app should be built, installed, and run. And the wonderful thing is that gets packaged into a heart artifact. We say it's because we heart you, though it actually means Habitat artifact. And that package can then be exported into almost anything. It can be exported into a Docker container. That's by far the most popular exporter that people
really,
can
it's by far the most popular.
Absolutely. We have had customers say, we have this legacy software, we need to get into containers. And that is something that Habitat does very, very well. As long as you know how to deploy the application, we can get you into containers, but moreover, once you create that heart artifact, let's say you want to try Cloud Foundry. We have a Cloud Foundry exporter. You don't have to rewrite the app to run it in Cloud Foundry. All you need to do is export it into our Cloud Foundry format. We have Helm charts for Kubernetes. We really take the view that there is no one true way to deploy an application. It all depends on what's best for your application at that particular time, and it's probably going to change. So we provide an easy, agnostic way to export your application wherever you need to and deploy it almost anywhere. Now, the other element is the runtime element. And what that is, when you run a Habitat package, whether it's in a container, bare metal, VM, whatever have you, we have what's called the Habitat supervisor. So that's what actually unpacks and runs and manages the packaged application. And the wonderful thing about that is you can have several instances of that Habitat package running. We call those services. Those make up what we call the supervisor ring, and they become aware of each other and can self-organize into different topologies. A really popular one for databases is leader-follower. So once I start up my supervisor ring and I say, hey, I want this in a leader-follower topology, they on their own will elect a leader. We have a built-in algorithm that runs that election for you. And then if the leader goes offline for some reason, the other services in that service ring will realize, oh, leader's not here anymore. We need a leader. We have a contract that we need to have a leader. Let's elect a new leader. And they do that without any human intervention, without any central orchestrator intervention. We want the applications to be intelligent enough to do that on their own.
So it's monitoring all the nodes, really.
Correct. Yeah, exactly. We use what's called a gossip protocol. That's how all the nodes stay aware of each other and communicate whenever there's changes, like one member goes offline or there's a new leader that's elected, etc. So it really puts that intelligence in the, I don't know if I want to say the hands of your application, but in your application is intelligence.
It's a learning mechanism.
Exactly. Yeah.
Okay. And so you use the Gossip protocol as a learning mechanism.
Right. As a discovery mechanism.
As a discovery mechanism.
Yeah.
Okay. And so with that discovery mechanism, then you then are able to then have that capability then to have that resiliency.
Exactly. Yep. We, 5 years ago, 10 years ago, we thought we can anticipate every way the application might fail, and then we add in contingencies for that. Well, our view is it's going to fail somehow. It's probably going to fail in a way that's completely unpredictable, because that's just the nature of Murphy's Law and life. So we want, no matter the reason for the failure, want your applications to be able to recover very quickly without any other intervention.
Without any other intervention. And so without that intervention, then it allows you then to, basically maximize the resources that you have.
Exactly. Yep.
And what are those resources then?
Let's see here. It makes it so the big one is, I'd say, mean time to recovery is much faster. I mean, if you have a website, that website goes down even for a few minutes, you're losing money.
Right.
Or you're losing potential customers and discover availability. So having your app, you don't need to page someone necessarily to get your application back up if something goes down. It has the intelligence to recover from that failure on its own. Now, you can set it to alert you if that happens, and that's probably something you're going to want to know happened when you wake up the next morning, but it makes it so that you recover much faster. That's one of the resources that it saves.
So you mentioned that you're seeing a lot of exporting into Docker containers. Correct. How and other means, how has that affected the development of Habitat over the past year or two as you see more people use container technologies?
Right. Big thing, lots of enterprises are doing this now. They have these big legacy apps. It's running on a physical server somewhere. They know they need to get that into the cloud for all the benefits of the cloud, and they know they want the benefits of containers as part of moving to the cloud. So we find it's extremely useful for someone who has an existing application. They say, I don't want to rewrite this, but I want to get it into the cloud. We make it super easy with that packaging format to package it as a heart artifact and then again export it into whatever is most appropriate.
There's a degree of migration involved.
Correct.
Here. Right. But you announced some new things here at the conference. Can you go through those?
Absolutely. The biggest one is the on-premises depot. So we've had a public depot available, and that's where our community can share Habitat packages. I'm the lead on the core Habitat origin, which is where we have a lot of core packages that people can pull in and use to build their software. A lot of our customers came to us and said, we love this public depot, but we're in an air-gapped environment, or we have corporate restrictions. We can't pull these from the public internet, and we can't put our stuff on the public internet. So we said, all right, we will create an on-premises depot for you. You can run it behind your firewall. You get all the benefits of Habitat packages, making it super easy to pull them to wherever you need to, but you can do it on your own infrastructure. We don't need to know what you're putting in your depot.
Right. So that's in place, and there's also the concept of the operator that you introduced.
I did. So the operator is a Kubernetes operator, Kubernetes controller that makes it very easy to run Habitat with Kubernetes. When we first announced Habitat, a lot of people asked me, why are you trying to compete with Kubernetes?
Right.
And the truth is, we're not. We work well with Kubernetes, and the operator makes that integration between Habitat and Kubernetes very seamless. And the best thing is you can use the same operator for any application package with Habitat that you want to run in Kubernetes. You do not need to have a separate operator for every application that you want to run in Kubernetes. So it's generic and makes it a lot easier, I think, to move your stuff into Kubernetes in the first place.
So operators are, caught a lot of people's attention at KubeCon this year, and you're seeing more applications use them.
Correct.
It functions as a control plane.
Correct.
And Habitat in itself is a control plane, would you argue, or would you say that Habitat is the packaging. Habitat's more the packaging mechanism.
Habitat is ultimately a packaging mechanism.
And so,
Yep.
with the operator, then what does that provide the user?
They can use both the Kubernetes CLI and the Hab CLI.
Okay.
Right, they both work together.
Okay. And so, how does that make it? How does that make it better for the customer? How does this allow the customer to, be able to use that kind of Kubernetes core that you have out there, right? Which is a powerful, is a powerful infrastructure software capability. How does it provide that customer with the capability to just optimize their use of Kubernetes and the Chef environment?
It's a good question. I'd say it makes it possible to run the Habitat supervisor within Kubernetes. So you get the benefits of the supervisor, being able to have the different topologies, easy to transmit configuration changes from service to service within Kubernetes.
Okay. So now with Habitat, there's questions about abstractions that come up.
Right.
And and so we're almost creating a new set of abstractions here.
We are.
There's historically been trade-offs.
True.
With abstractions, and Adam brought those up a little bit today.
Right.
What are those trade-offs?
Well, one of the big ones when I talk to people about cloud computing is when you are with a cloud provider, the higher the abstraction gets, the more locked in you tend to be into that cloud provider.
Right.
One of the wonderful things about Kubernetes when it came out is that Kubernetes makes it so you can have that high-level abstraction, but be easily portable from cloud to cloud.
The portability from cloud to cloud.
Correct, yeah.
Now, I've been wondering what's the importance of that, and I'm starting to see more clarity on that, because often, I think human behavior dictates, if this is easy, I'm often just going to just keep doing what's easy, right? So if I can push a button in AWS, then I have a monitoring, and for a monitoring tool, right?
Right.
Then I can do that, right? But now when you're moving into but if you're a company and you are monitoring a service that might run in a different deployment somewhere, that's where the complexities arise.
That is correct.
So tell me about that, how you view that complexity.
Right. Well, I can tell you, I'm not going to say which service it was. I've worked on a number of political campaigns, and we had a cloud service appear to go down on election day, which it turned out it wasn't actually down, just the API wasn't updating the way it was supposed to. But with something like an election day, you can't move that. There's absolutely no do-over. So my personal resolution coming out from that is anytime we use any service, whether it's ours or cloud, I'm always going to have a backup if it's something like an election day, which is so high stakes. Can you repeat the question one more time?
Oh, I just was curious about your view on those complexities that come with that. There's a lot of talk about multi-cloud and portability, and there's a lot of talk about then, Kubernetes kind of filling in that role, and Habitat kind of plays in that role, but it creates some new complexities with it too.
It can at first,
and because if you're using a service, right, like AWS, you don't have to worry about those complexities if you're just using that one service. As your application gets to a certain size and a certain amount of complexity in the application itself. Yes.
That is correct.
Now, if you're deployed across multiple cloud environments, pressing a button in AWS may solve the issue for AWS, but what about those other architectures out there? So that's I think that's a complexity that I'm thinking about here.
One of the nice things about Habitat is we have a standardized REST API layer on top of anything that you're running with the Habitat supervisor. So no matter which cloud it's in, no matter what kind of infrastructure it's in, you can communicate, get information in and out of it in the same way. So I'd say that is one of the advantages of Habitat when it comes to dealing with that multi-cloud complexity, or even multi types of infrastructure complexity.
Right. So now we're getting, one of the things that Adam talked about, and we're going to be talking to him later as well, but I'm just curious in your perspective about this, is the one issue that seems to be has surfaced as we've seen, infrastructures evolve, right? There's always there always are those trade-offs.
There are.
And one of the big trade-offs has been around contracts, hasn't it?
Right.
And what have been those trade-offs? What have been those trade-offs that you've experienced in your career that have come with abstractions, and and how it affects the contracts?
The biggest one, I'd say, I don't know if it's related to contracts, when it comes to abstractions, is I used to work for a hosting company. When Chef was introduced, there was a lot of fear that if we were operating at this higher abstracted level, that would mean that really specialized system knowledge that so many of our employees had spent decades building up would suddenly become useless. So I'd say the most common issue I see is not necessarily a technical one, it's a human one, in that there's an element of fear. Does this abstraction make me irrelevant?
And so that's a people problem.
It is. A lot of technological problems are actually people problems.
Yeah, they're big people problems. And so that's something you can't necessarily control, except to do what? To put it in context of DevOps principles?
Put it in context and show how those skills are still valued. I mean, you can't automate something if you don't know how it works at the lowest fundamental level. You need to know how the manual process works in order to automate it. And if that automation breaks, you need to know the manual process to be able to fix it. So that knowledge is applied in a different way, but it is still very, very vital.
So when you're thinking about, the emerging use cases that you're starting to see with Habitat, what are those? And some of the more what are some of the more established use cases that you're starting to see? Right.
Established one is getting a legacy application into the cloud.
Right.
Let's see, another established one.
So what they're doing is, so again, and we've talked about this a little bit just before, earlier in the conversation. How are they using the Chef toolchain with Habitat? In that migration, we're seeing Chef Automate, correct?
Right.
And then when they're using Chef Automate, then how, what is it then where the Habitat tool comes into play? Right.
Well, Chef Automate 2 is built on Habitat.
Okay.
That is a part of it.
Yep,
so it works very, very well with it. Combining Habitat and Chef Automate, among other things, you can use Chef Automate to spin up or to deal with the actual physical infrastructure that your Habitat applications are going to run on. And then Habitat focuses on the application rather than the infrastructure itself. The idea with Habitat is it doesn't matter what infrastructure the application runs on, it's going to run exactly the same, but you do still need to manage that infrastructure, whether it's cloud infrastructure, whether it's a data center, you still need management for that, and Chef and Automate 2 provide that very nicely. Additionally, what Automate 2 also includes is compliance, which allows you to scan all of your infrastructure, and we're getting to a point where we can use it with Habitat 2, though that's still being proven out. Make sure that any ports you need closed are closed. We have profiles you can download to use with compliance saying, hey, I need FIPS compliant hardware. Here's a profile I can use to automatically scan my hardware to make sure it's FIPS compliant.
I see. And so what are some of the emerging use cases that you're starting to see?
Right. With Habitat,
are people using it with Kubernetes? And
they are. Thank you. That is one of the big emerging ones. People want all the benefits of Kubernetes. Kubernetes is hard to set up, though. And which means cloud services like GKE, AWS's emerging Kubernetes service help with that quite a bit. But people want the power of Kubernetes, but still want to easily be able to interact with their applications using that HAB API. So we are seeing that emerge now, where people who are just getting started, even just getting started with their Kubernetes deployment, still want a way to easily get information in and out of those containers.
Yeah.
And so they are using Habitat for that.
Right. So, when I think also of Habitat, I think of continuous integration and continuous delivery. And the traditional methods for continuous integration have largely been around instrumentation to some extent. How does Habitat shift the game? How do you feel it shifts the game? Because we're starting to see continuous integration, continuous development environments starting to emerge in Kubernetes. We're seeing, Jenkins for continuous integration. It's been a fan favorite for a long time. But now what we're seeing with continuous development, you guys like to call it continuous automation.
Right. It's continuous something.
Yeah, continuous something. You're starting to see a need to have, more observability. We're starting to see this kind of concept of observability really emerge. With that comes then the need to really understand the patterns, right? Which are based on the monitoring, which are based on the alerting and other factors. And then once you're able to establish then those patterns, you can start using like Prometheus, for example, underneath, like to be able to really be able to understand what the data is and better comprehending the observability, better getting a better understanding of what was actually happening. So, is that a big play for you then to create this continuous delivery environment? Right. Is that what you're trying to really do here?
The biggest thing we can offer with continuous delivering environments, which we do with the public builder, is dependency management. Mm-hmm. So one of the things we've noticed when we build applications is that we'll have our application itself, but it's going to have 5 different dependencies. Each of those dependencies has 6 different dependencies, and it builds exponentially from there. What Builder, the Habitat Builder, which is, we currently only have a public builder, but what that allows us to do is anytime you update a package, it will automatically rebuild and update all of the packages that are dependent on that package, and then all of those dependencies, put them all in an unstable channel. So all you have to do is log into Builder and see that you have a new unstable version of one of the dependencies, and then you can evaluate it, and if it looks good, you can easily promote it to the stable channel. So that kind of effortless dependency management, I would say that is our biggest play when it comes to continuous delivery.
What then does the developer or the operations person need to do to prepare the artifact in the container? I'm thinking about the build process of the container itself.
Builder has an automatic integration with several container services. So once you upload your package to Builder, you can either upload it personally or you can add in a Git hook. So every time you update the package on GitHub or the application on GitHub, it will automatically rebuild the package on Builder. And I'm sorry, can you repeat the question one more time?
No, and I was just curious about that Builder environment. It's an interesting space now. We're starting to see more Builder tools emerge, and I think one of the vagaries of containers has been, what do you put in your container itself? How do you build it?
Yep.
And now we're starting to see build tools emerge, and policies establishing. So almost those containers are almost predefined to some extent.
Right. I gave an interview recently where I talked a little bit about container anti-patterns. And one of the biggest ones is starting off building your container by putting an entire operating system in it. Yes. Number one, it makes the container unnecessarily large. Number two, you have a huge security vector. I'm blanking on the exact term right now, but you have a large vulnerability, because if any of those parts of the operating system have a security vulnerability, then that's baked into your container image. Right. So what the Habitat exporter does, which is really nice, when we take that heart package, export it to a Docker image, is it starts with just bin sh for a Linux container, and we only pull in just what is needed to run the application and absolutely nothing more. So rather than starting with an operating system, adding in dependencies, then adding the application, we flip that on its head. We say, let's start with the application, have the application drive what dependencies it needs, and have those dependencies drive exactly what parts of the operating system it needs. Let's put that in the container and absolutely nothing more.
Mm-hmm. So we've talked a lot. Gone through a number of topics here.
Right.
Just talked about the builder. We talked about the use cases, what are emerging use cases, what are some existing use cases. We discussed how the basics of Habitat and the operator with Kubernetes. What do you guys see as the direction for Habitat from here?
It's a good question. I'd see getting more real use cases, which we're in the process of doing. I'm not sure which ones I can talk about and not talk about right now, but showing how much easier it makes for enterprises, number one, to get their legacy applications in the cloud, to manage those applications in the cloud or not in the cloud. They prefer on-premises data centers. We have some government customers where the stuff needs to stay in-house. And for people who want to easily manage all the dependencies of their application. That is a story we hear constantly. I have all this software that my company's built, even if the company is not a traditional software company, managing all the dependencies is killing my business's velocity. So Habitat, I see it taking on an even bigger role as we've rolled out on-premises Depot and as we perhaps add in some functionality from Builder, making that dependency management much easier.
Mm-hmm. And those dependencies are only going to get more complex.
Oh yeah, they only are.
Yeah, right.
I tell people I took computer science, my first computer science course in 2003 or 2004, and I had to download maybe 3 things, and now it's over 100.
Wow.
Every time I'm developing even a relatively simple application. So that problem is only going to get worse, and I think Habitat is landing at exactly the right time as businesses feel the pain of those problems.
Mm-hmm. Mm-hmm. Well, great, Nell. Thank you very much for taking the time.
Thank you so much for having me. Yep.
We'll have to have you back on the podcast. It's always nice to interview a fellow podcaster. So
Absolutely.
Thanks for taking the time.
All right.
And a talented engineer too. So,
thank you. We'll have to get you on Food Fight Show as well.
Love that.
All right. Have a wonderful day.
You too. So thanks for tuning in to another episode of the New Stack Makers, sponsored by Chef. As always, thanks for listening, and please subscribe, rate, review us wherever you get your podcast from.